Hey guys, today's question is split linked list in parts. In this question, we are given with the linked list and an integer k, and we have to split the linked list into k parts. Also given, the length of each part should be as equal as possible, and no two parts should have size differing by more than one. Okay, and the size is differing by more than one. So if the any of the size of the partition is greater, then it should be in the left part. As in the example, let's see example one. The head is 123, linked list is 123, and k is 5. So as you can see, the number of nodes in the linked list is smaller than k. Then in this case, we can simply put every element distinctly in the linked list from left to right, and total k minus count times, as the count is 3 here, total number of nodes, k minus count times we have to push the null value in the vector. And in the second case, we can see as the number of nodes in linked list is 10 and given value of k is 3. So we can split linked list in 3, 3 and 4 parts. Okay, but point to notice, this 4 parts cannot be in the right. Like we cannot split the linked list like 1 to 3, then 4, 5, 6, and then 7, 8, 9, 10. We can't split like this because in the question given, the part should be in the order of occurrence, and part earlier should always have a size greater than or equal to part occurring later. Okay, now what we can do in this case, in the first case, we can simply push all the values differently in the vector, but in this case what we have to do, we will first divide the value and we will get the division. So in this part, the total number of nodes is 10, so count is 10. So 10 by k, 10 by k is 3, 10 by 3 is 3.33, so 10 by k is 3. So we have to make 3 parts. Sorry, the smallest size of the partition will be 3, as given value of k is 3 and 10 by 3 is 3, and the remainder is 1 here. Okay, so for starting one partitions, we have to add one more value. Okay, as visible, if we push only 3 values, then only 1, 2, 3, 4, 5, 6, 7, 8, 9 will be pushed in the vector and 10 will be remain. But in this, we will just simply count the remainder, and for the first remainder times partitions, we will push one extra value so that we can cover all the values. Okay, let's go to understand more. Let's first take the integer variable I. First we have to count the number of nodes, so let's take count as 0. Now we also have to return the vector of list node type. Let's take that, let's name it as answer. Now we have to use some pointers to iterate over that, so let's take ptr as head. Also let's take a pointer as temp. Now first we will count the number of nodes in the linked list, so while not ptr, while ptr not equals to null, we will simply increment the value of count and we will move ptr to the next location. Ptr equals ptr next. Now as we have counted the number of nodes, let's again mark ptr as head because ptr is null after the whole iteration. And after that, as we will simply do this question in two cases as I discussed. So first case is the value of number of nodes is less than or equals to k. Then we have to make total k partitions. Okay, so of size 1. So let's write that. First case, if the count value number of nodes is less than equals to k, then first we will push the values of all the values of linked list. Answer dot push back node ptr. And now, like in this case 1, 2, 3, when the push 1, we also have to mark its next pointer as null because it is a single linked list, as we are dividing this linked list into k parts. So we have to mark the next pointer of this as null. So before marking it at null, we also need to jump to the next pointer. So that's why we are using two pointers. Let's take temp as current value. Now we can mark temp next of the temp as null after moving ptr to the next value, next location, sorry. Now temp of next can be marked as null. After this while loop, as we discussed, for k minus count time we also have to push value null. So let's write for that, for I equals to 1, I less than equals to k minus count, I plus plus, we will simply push value null. Answer dot push back null. Now we covered the first case, let's cover the next case. For this case, when the value of count is greater than k, first we will get the division and remainder value. So division will be simply equals to count by k, number of nodes divided by given k value, and remainder equals to count modulo k. Now let's run the loop again while ptr not equals to null. Now as we have to only remainder times, we have to put one extra value. Okay, as the value of 10 divided by k equals to 3, so the partition was 3 3 3, but for the remainder times, as the remainder was 1, so in the starting one partition we pushed one extra value. So for that we can use, so we will decrement remainder one by one till the remainder is 0, and for in that cases we will push one extra value. Okay, so let's write first case, if remainder is not 0 or greater than 0, simply we will simply push the current value, which will be the starting of the new partition ptr, and now we have to move to the, as we push the value 1 here, and we have to move to till the 4 to make its next as null and shift to the next pointer. So equals to 1, I less than equals to division, as the value of k division was 3, so we shifted ptr from here 1 to 3 times. Okay, and after this let's increment I, and ptr equals to ptr next. So by doing this operation, what we did, we pushed the value 1 in the vector and we moved till this value 4. Now we have to make the next of 4 as null, and we have to shift for the next value. So for making it null, we will simply do like this. Let's just simply copy this and paste here. Okay, temp equals to ptr, ptr equals to ptr next, and temp next equals to null, and this case is for remainder greater than 0, so we will also decrement the value of remainder. Now in the else case, if remainder is not 0, that means we have pushed one extra value in all the remainder times partitions. Now we have to push only 3 or only division time values. Okay, so let's write for that case else condition. First we will push the current head of the new partition, so answer dot push back ptr. Now for I equals to 1, I less than division, as we have to push one less value, so that's why we took I to less than equals to division, and here not equals to, only I less than division, so that one less value will be pushed in the vector. Simply ptr equals ptr next Let's copy this again to delete a node to make the next of the current node as null. And after all this, we simply have to return our vector, so return answer. Let's run this. Okay, we missed some braces here. Okay, let's run again. Let's submit this. So the code is accepted. Thank you for watching.